Hello my dear students, welcome back to my class. In the series of learning programming in C, in the previous video, we have discussed about double pointer. In today's video, we will discuss about a new topic and the most interesting topic, which is pointer arithmetic. So, this arithmetic operation is very special on pointers. So, all the arithmetic operations cannot be performed on pointers. So, let us see which are all the operations, arithmetic operations that could be performed on pointers one by one with example programs and with execution. We'll see practically how these pointers are going to operate on arithmetic operators in detail with execution. So those are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Pointer arithmetic. As the name itself tells you, we are going to perform the arithmetic operations on pointers. So what is pointer arithmetic? Pointer arithmetic allows to perform arithmetic operations. So which are all the arithmetic operations? It may be addition, subtraction, increment, decrement also. So we perform those operations, but how we are going to perform, we have to see that through programs. So we can perform arithmetic operations on pointers. Then, why we have to perform arithmetic operation on pointers? So when we say we are storing the elements into the array, sometimes it is quite difficult to access the elements of the arrays one by one or randomly. But we can do that using pointers. Through pointers, I can access the array elements very easily. So I can navigate through arrays. So when I use pointer arithmetic operations, I can easily navigate through arrays, and sometimes I may also manipulate the memory locations also. So using pointer arithmetic, we can perform arithmetic operations and we can navigate through arrays and we can sometimes manipulate the memory locations also. But how it is going to deal with means the resulting address depends on the size of the data type the pointer is pointing to. It's not like normal addition or subtraction. It is quite different, that is with respect to the size of the data type the pointer is pointing to. So how it is going to do that operation, how it is going to perform that addition or subtraction with the address, let us see with some example programs. So let us understand this pointer arithmetic with simple example program. So here in this video, we will see how to perform pointer addition. So we will deal with pointer addition. So how we can perform pointer addition, let us see. Okay. Now here we have an array initialized with these values. So let me write the memory allocation for these. So here, let us take the 32-bit machine representation. So it is 4 bytes for integer value. So let me write how many values we have stored? 3, 4 and 5. So that is the elements we have 10, 20, 30, 40, 50 and it is A of 0, 1, 2, 3 and then 4. So let us say the address is allocated from 1000. So 4 bytes. So it is 1000, 1, 2, 3. Totally 4 bytes for A of 0. 1004, 5, 6, 7. 1008, 9, 10, 11. 1012, 13, 14, 15, 12, 13, 14, 15 and 1016. So 4 bytes we have taken. And when I say A of 0, it always take the first bit address. It always take the first byte address. So total 4 bytes. So first byte address it is going to take. Now let me have an integer pointer. I say integer asterisk p. I say a. You can say a or you can say, for better understanding, you can say ampersand of A of 0. It can be ampersand of A of 0 or you can simply write it as A also. Both are one and the same. the array name will give you the base address that we have seen in the previous program. So it is ampersand of A of 0. So we have a pointer variable P, and this P is pointing to the address of A of 0. So it is pointing to this location, means this address I will have here. So P is having, and even pointer also will have some address. So let me say the address is something like 2000 for this. Okay. Now I need to say I perform the arithmetic operation. So what I will do, I'll just say pointer P we have used. I say P equal to P plus 2. So when I say P equal to P plus 2, what we think? What do we have in P? It is 1000. We normally calculate in the normal addition method. We say P is having 1000. 1000 plus 2. So my answer is 1002. No, it's wrong actually. It is not going to perform the normal addition, but as I said, it is going to do the arithmetic operation with respect to the size of the data type to which it is pointing to. So here, when I say P plus 2, it is not 1000 plus 2. It is with respect to the size of the data type. So internally, what the compiler is going to do for this, it is going to calculate like this. P plus 2 into size of the data type. So what is the size of the integer? So if it is 32-bit machine, so let me take it as 4. So it is P, what is P? It is 1000 plus 2 into 4. So it is 1000 plus, see, you need to do all the arithmetic evaluations here. Say multiplication you need to do first. We have to follow the Bodmer's rule. Operator precedence we need to follow. So it is 1000 plus 2 into 4. It is 8. So it is 1008. Means to say it will point to 1008. So the new value for pointer, that what we have got is 1008. So it is not the normal addition. So it is P equal to P plus 2. I am adding integer. Say I can add an integer value to a pointer, or if any data type, it may be float also. Means I can say I can add a value to a pointer, but that value will not be added in a normal way. It will be added with respect to its size of the data type to which the pointer is pointing to. Now, when I say P plus 2, 2 here, it is the size of integer what it is going to take. So what is size of integer? If it is 32-bit machine, it takes 4 bytes. So it is 2 into 4, it is 8. 1000 plus 8, it is 1008. Now the new value for P is 1008. P plus 2 means 1008, not 1002. It is 1008. So now it is pointing to 1008, means to say it is pointing to the third element. So when I say 1000, the base address plus 2 means it is pointing to the third element. 1008, it is pointing to the third element. Or in general, you can just say it is nothing but pointer plus n is equal to address of A of 0 plus n. So P plus n means, if I just say P plus 2, what happens with respect to P plus 2? It is nothing but it is equal to point to the location of 0 plus n. 0 plus n means 0 plus 2. So it is ampersand of A of 2. So what is the address of A of 2? It is third element. Hope you have understood with this. How this value. So now we are doing with integer pointer, how an integer value is added to the pointer. So the first operation that what we have learnt is we can perform the addition operation on pointers. Means to say we can add a value to a pointer. Right? We can add a some value to a pointer. If it is an integer pointer, I can add integer value. If it is a float pointer, I can add a float value. And depending upon the size of the data type, it calculates. Right? So I can easily navigate to the array values and I can change the memory locations. That is what we have understood till now, right? But you cannot perform one more thing, the normal addition. Say for example, I have one more pointer variable. I'll declare one more pointer variable and I'll make this pointer to point to the address of a of 0 itself. Now what I'll do, I'll say p equal to p plus q. So you have a pointer variable q, even q is pointing to the location. See, p is also pointing to 1000 and q is also pointing to 1000. When I say p plus q, what is p? It is 1000. And what is q? It is also 1000. So 1000 plus 1000, it is how much? 2000. This operation you cannot perform. So you just can't add the addresses like this. This is wrong. So this you cannot do. You can only add some integer value, some value to the pointer. Let me comment this. So what I can do, I can say p equal to p plus 2. And if I just say printf, print the value equal to %d asterisk p, and printf address equal to %u, then print p. So what will be the answer? P equal to p plus 2 means how much? P plus 2 into the size of the data type. So it is 4, 2, 4, so 8. So it is p plus 8, 1000 plus 8. So it will be pointing to this location. So 1008. So it is pointing to the third element. Now if I just say asterisk p, p is having 1008, value at the location 1008 is, it is 30. Then what is p? It is 1008. So this is how you can perform the addition. Now let me say after this, once again I'll say p plus 2. Then I'll say printf value equal to %d, then I say asterisk p. Then I say printf address equal to %u, print p. So what happens here when I say p plus 2? Here I have not assigned this p plus 2 to any pointer. So here you don't have any meaning for this. You need to assign this to the pointer. So now when you say p equal to p plus 2, so p right now it is 1008, right? It is 1008 plus 2 means 2 into the size. Size is 4. So 2 into 4 it is 8. 1008 plus 8. So what is 1008 plus 8? It is 1016. So it is pointing to the location 1016. Now the pointer is pointing to 1016. So you need to assign like this. Then if you say asterisk p, what is the value at 1016? It is 50. What is p? It is 1060. So now what I'll do, p equal to p plus 2. Then later I'll say p asterisk p equal to 60. Now what will be the answer for this? P equal to p plus 2. P is right now, it was pointing to 1008. Then I say 1008 plus 2. 2 into 4, 8. So it is 1008 plus 8, it is 1016. Okay. So now the pointer is pointing to 1016. Fine. Then what I will do, asterisk p equal to 60. Observe this. P is pointing to 1060. Point to that location and store 60 means I am going to get a new value here. And now if I just try to print asterisk p, what will be the value? It is, p is pointing 1060. I have changed this. So asterisk p equal to 60, and what is p? It is 1060. So this is how we can perform the addition operation on pointers. So we can add a value to a pointer. Pointer addition means adding an integer value to a pointer if it is an integer pointer. So we can add value to a pointer. Two different pointers or two pointers cannot be added. So previously we saw we just can't add two pointers. It is wrong. We can add some value to the pointer, and that value will be added in a special way. It will be added in a special way in a sense it will be calculated with the size of the data type. So it is p plus 2 means p plus 2 into the size of the data type. So if it is integer pointer, it is 4. 2 into 4, it is 8. So it is p plus 8. That is what the addition operation with respect to pointers we are going to do. The remaining operations, how to perform the incrementation and how to perform the subtraction, we will have separate videos for that. Now let us see the execution of this. So here we have the program. So I have declared an array by name A and initialized the value 10, 20, 30, 40, 50, and we have a pointer variable by name P, asterisk P. The first thing that what I do here, I say P equal to ampersand of A of 0, means I am storing the address of the first element into the pointer variable P. Then I say asterisk P. So let me comment all these things first. Okay, I'll just say, let me comment these things. So now I'll say print the value of P, means asterisk P. So what is P? P is storing the address of the first element, right? So some address it will have. Point to that location means it is going to print 10. So what is the address? Some address it will be holding means it is holding the address, the element address, the first element, the base address. You can also write it like this also. So you can simply say A also. That is also fine. So for a better understanding, it's better to write like this. So let me save this. Control F9. Look at here. So value is 10. So it is pointing to the first element of the array. And the address is 65516. Okay. Now what we'll do? We'll say P equal to P plus 2 means plus 2 means 2 into with respect to the size of the data type. If it is 16-bit machine, it will take 2 bytes. If it is 32-bit machine, it will take 4 bytes. Okay. And then print the value. Means P plus 2 means it has to point to the third element. Okay. Now let me save this. So it has to point to the third element now. What is comment I have not deleted. Save this. Say Control F9. Look at here. See, it is pointing to the third element, 10, 20, 30, third element. And it is with respect to 2 bytes it is taking. So it is 16, 17, 18, 19 and 20. So 16-bit machine. So it is taking 2 bytes. So 65520 is the address of the third element. Now what I'll do? I'll say point to the third element, then change the value. I say asterisk P equal to 89. Now let me say print that value. So what it is going to print? So it is not going to print the value 30, but it is going to print 89. So let us see that now. So I'll just say Control F9. See, value equal to 89. Right. Now let me say I have one more pointer variable. I say asterisk Q. Then I'll say Q equal to, let me say even that Q point to the address of A of 0 itself. Then I'll say P equal to P plus Q. Okay, now let us say what happens. So P plus Q, this is addition once again, but what I said, I just can't add one pointer with another pointer. I can add a value to a pointer, but not pointer with pointer. So let me save this. Control F9. See, there is an error. It says invalid pointer addition. Got it? So this you cannot do. So this is how we can add the value to a pointer. you can just convert this complete program to access all the values through pointers using for loop also. For that you can just say, so here we are having values p plus 2, p plus 2, again and again we are doing, right? You can simply say p plus I. So how to do that? So what I can do here, so I'll just say, I'll just remove all these things. Now let me have p equal to ampersand of a of 0, that is fine. Let me delete this extra pointer variable. Pointer p is sufficient. Let me have an integer variable for loop. This is extra program that what I am adding here. So what I'll do here, I'll say printf array elements. So I'm trying to print through for loop. So how we can do that? That is what I'm typing the program, and it's an assignment for you people to analyze this, how it is going to work with for loop, and please write the complete answer in the comment box. So let me know how well you have understood this pointer addition. So what I'll do here, I'll say for I equal to 0, I less than, say 5 elements are there, let me type 5 only, I plus plus, then I'll say printf percentage d tab space, then I say asterisk ptr plus I. Okay, so here you must analyze how it is going to work. So asterisk, so I say asterisk ptr plus I. So you need to print the value. Asterisk represents value, that's it. But what is ptr plus I? So I said ptr plus 2. So it is not ptr, I'm sorry, my pointer variable is p, right? So I have to say p plus I. Okay, fine. So it is p plus I. So what is p? The address of the first element. Plus I, for the first iteration it will be 0. P plus 0 into the size of the data type. So if it is 16-bit machine, 2 bytes. So it is p plus 0 into 2, it is 0. So p plus 0 means it is the first element itself. Then again I gets increased. So I into the size of the data type. Again p plus I into the size of data type. I will be changing. So you have to write this tracing and tell me the answer in the comment box. And this is what the assignment for today's video. Hope you have understood this. Well, output will be the values 10, 20, 30, 40, 50. We'll see that also. Save this. Control F9. See 10, 20, 30, 40 and 50. So this is how I can print through for loop. This part asterisk p plus I, you have to trace it out, you have to analyze, and you have to tell the answer in the comment box. That's all for today's video. See you in the next video. Till then, take care. Bye bye.